Hello, listening. All right, let's start first. We'll make a few announcements on the second hour when more people are here. Okay, so I posted out one example done by Haran. It's on the example 5.42, integrating 1 over cos x dx or integrating secant x dx. So he used a rather different method where he choose to integrate 1 over sine x first, and then he relate back to 1 over cos x. Okay, so you can have a look. So they got the same answer as us, which is long secant x plus tangent x. Okay, so you can have a look. I posted out in the notes already. Okay, in the Moodle, in the notes, I have updated. So you can compare the two methods. Okay, so far so good. Okay, so you can check it out. Yeah. Uh, so from last Friday, right? We are finding the volume, okay, using integral. So what's the idea here? So the idea here was we have a Riemann sum by rectangle, and we want to find an area under the graph. Okay, so area under graph you can think of like a bunch of infinitely many straight line. Okay, but how you get these straight line is you getting from the rectangle. Okay, the rectangle here. Okay, and then you take the limit of this rectangle, the width of the rectangle go to 0. So the dx that you integrate, right? You can think of it as some thing. Let's here. Okay, maybe I move here. Okay, so when you do this definite integral, right, in the geometry sense, this dx here, okay, this dx here you can think of as the thickness. Then fx is height. And then this integral sign is the limit going to 0. Limit of thickness. Okay, so this is the geometric meaning. Okay, the geometric meaning of the integral. Definitely. Okay, does it make sense? Okay, so this is the, can I put somewhere kind of squeeze down? Um, right somewhere. Size. Okay, so this is the geometric meaning. Geometric meaning of standard. So we generalize this idea to finding volume. Okay, instead of line, we look at something like this, or something like the square, or something like the annulus. Do you know what's annulus? This is an annulus. There's a like puncture in the middle. There's a hole in the middle, and then or triangle. Yeah, and then we look at we slice our spaces into circle, cylinder, or annulus. Okay, and then we also use the some kind of thickness. Okay, so if we put some thickness on this, we kind of get like a pancake, right? Or we put a thickness on the square, so it's like a box, and the rest are just prism, just prism. Okay, depend on how you orientate your triangle or circle. Then the thickness could be sometimes in dy or sometimes in dx. Okay, your thickness is in the x direction or in the y direction. It depends on this how it's like. Okay, so this is the one that we left last time. For example, revolving about the horizontal line. Okay, you know the circle or the contribution of pi, and revolving around vertical line. Okay, so should I draw the line for you? So let's draw the line. So maybe this is your, that's this, or this is your y. You take the graph and then you revolve. You cycle up this. Then last time we have a washer method. Pi of r out squared minus pi r in squared. Because you take the outer circle, area of the outer circle, minus the area of the inner circle. So you will get rid of the middle thing. Okay. And then cylindrical. Okay, cylindrical is quite similar to a washer if you notice. Okay, but for cylindrical, you have the cylinder height. So what's the cylinder, the area of the cylinder, the volume of cylinder? Pi r, 2 pi r times h. And so you have a 2 pi, the radius. So here you got the radius, okay, and then you got the height. So 2 pi. For washer method, you just have pi r out square minus pi r in square. Okay. Uh, if you forget the number, I mean the example is fine because we're gonna do example again. But please keep this picture in your mind. I want you to keep this picture in your mind. How to slice the spaces out. Okay. And then for this course, maybe this part is not very heavy. But when you go into calculus 2, right? Everything about calculus 2 is slicing out the spaces. So maybe this part is the hardest part for the integral part, but in the next semester, everything you're gonna learn is about this kind of slicing of spaces. Okay. For now, you don't need to think of any example yet. I just want you to have an idea on how you can slice out your spaces. Does that make sense? Okay, later we'll do example to help you see how to apply this slicing. Okay, so far is it okay? I put this in the last lecture, I guess lecture 16. You can have a look on that picture. Okay, so far any question on this picture or not? For example, this kind of cylinder, right? You won't use triangle to slice it, right? A different shape. And so depending on what shape you get, you need to use a proper shape to slice it. Any question on this picture here? of this picture before we jump into examples? Any question on this picture? You can see a more clearer picture in your lecture notes. Lecture note 16, I put it in. Question? Is it clear on how I slice it out? So in particular, these two methods, right, you can see that they apply to very similar case. Okay, one cylindrical shell, one washer method. Okay, so why do we call it a washer method? It's like a washing machine. Every day you do your laundry, right? You need to put your shirt into the laundry washing machine, right? Okay. So this is like a greater circle, take away a smaller circle. But cylindrical cell is like you just calculate above cylinder. Okay, so did you see what's the difference between cylindrical shell and washer method here? You see what's the difference? No, cannot see. So to get, you see, these two pictures is the same, right? Almost the same. Okay, the red object is the same, but we slice it in different way. So if we slice it in cylindrical shell, right, to build out the red object, we just need a bunch of cylinder. Okay, we just need a bunch of cylinder in the x direction, from small to big. Right or not? So if you look at this shape here, okay, you from small you take it to big. You can fill up the cylinder. Okay, does it make sense? Make sense or not? Huh? Okay, for example, is if like this is a bag, right? Empty bag. If I want to fill the bag, I will put a bunch of books to fill it. So I can fill the bag. So this is like I put a bunch of cylinder inside. But here, I just put a bunch of circle. So I have a circle in x direction. It's not enough, right? I just fill one level. I still need to fill all the level of y axis. Okay. Does it make sense? Okay, it's not just enough to fill here. I need to fill from the top. Okay, so one is like in the x direction, you integrate. And then on the other one, you integrate in the y direction. Y direction. Okay, does it make sense? Make sense? Okay. So this is in the y direction. You can see that the thickness also happens in y direction. And then this thickness happens in x direction. Okay. So for example, if you look at our integral here, right, the thickness happens in the x direction. Okay, so you integrate over the x direction. And get this geometric meaning of this integral here. Later we'll try an example. So try and uh, understand the slicing of these faces. Okay, any question that you don't know how to read this picture? Okay, if not, let's try some examples. Okay, let's try these examples here. The region bounded by y equals to 1 over square root x. And then the x-axis, x equals to 1 and x equals to 4 is revolving about the y-axis. Find the volume of the resulting solid. Okay, so let's draw it. Let's draw the region first. So let's get our xy axis. 1 over square root x is looking something like this. It's always positive, so there's only one side here. And x equals to 4, 1, and 1. So it will be look something like this. 1, 4. Okay, we can quickly compute the intersection here. So if you put x equals to 1 to this y, you will get 1 over 1, which is 1. And then if you put 4 into square root, you get 2, so you get 1 over 2. Okay, it's indeed decreasing. So the region bounded by this curve plus x-axis, but this line is something. Okay, so this is revolving around the y-axis. So you have this direction. Okay, so maybe you have something symmetry on the other side. Okay, does it make sense? Yeah. Okay. Anyone can picture what's this? Is there any real life object that looks like this? Object that looks like this. Any real life object look like this? Nothing wrong. Cup holder. Cup holder. Do you have cup holder? Cup holder look like this. Yeah, any real life object that you can think of? Cup holder. Uh, the cup holder I find is like a Starbucks one. Not very helpful. Uh, yeah, if you know of any live objects, maybe you can let me know. I can show to everyone. Okay, but you can imagine that this piece of thing that we will circle. So what method you can use here? One method you can use here is to use the shell method. Okay? The shell method is like a cylindrical shell, so you use a bunch of cylinder to approximate it. Okay, so you can see that this cylinder have height depending on your function y. Imagine on the cylinder here. Okay, and then this cylinder here has radius like from x equals to 1 up to x equals to 4. And comment like this, we can use the shell method. So the cylindrical shell has radius x. Okay, so x is ranging from 1 to 4, and the height is depending on your y. So it's y equals to 1 square. Okay, depending on your y. So this height is very convenient because your height depend on x, and you know how you control your x. So for example, when x equals to 1, your height is 1. When x equals to 2, for example, your height is 1 over square root 2. So it's get control. So you think that there are two variables here, actually it's not, because the height is depend on x. So you just need to control one variable. Okay, you know your radius, you know your height already, because your height is depending on your radius. Okay, so actually it's one variable. In calculus 2, these two things is different. Calculus 2, these two things, height could change itself. And for now, everything is in one variable. Okay, so um, you are happier. Okay, so then by the cylindrical shell method, v is equals to the integration from 1 to 4 of 2 pi x times height dx. Okay, so here is the volume of your cylinder. Okay, and then dx is the thickness of cylinder, and then your integration is the thickness going to 0. Okay, so meaning you take a bunch of cylinder to build it. Okay, you take a bunch of cylinder to build it. So I mean integrating this, I think, is Simple, right? Let's see. Okay. So this is integrating 2 pi square root x of dx, which is 2 over 3 times 2 pi of x to the 3 over 2. Okay, finding the antiderivative, evaluate at 4 and 1. I think you get 23 over 3, 28 over 3. Okay, so this is the cylindrical shell method. Okay. Similarly, you can use another method. Okay, we can use a washer method here. Okay, so what's the washer method? Let's do it in another way. Let me show you the other way. Let's remove this thing here. Okay. So let's draw the shape again. We're gonna slide this shape in a different way. So let's draw it again. So let's keep the purple part only. So we know where it comes from now. Okay. So another way we want to see it is we use a bunch of circle to build it. Okay, we want to use a bunch of circle to build it. So for example, we want to use this annulus to build it. So how does our annulus look like? So our annulus will look like this. So this is the R in, the R out. And you can imagine what are the levels we need to consider here. So we need to consider all the way from the so we start at y equals to 1 until y equals to 0. Okay, so this is called the washer method. So we can say that the washer has R in. So R in is kind of fixed here. So let's fix it. R in is always one unit, depending on what's the unit you use. And how about R out here? Okay, we can see that the R out here, right, is but here got fixed. Okay, so in a different height, your R out is different. Can you notice it? We are up here. Okay. So here, this line have we computed is 1 over. I drew a bit too high now. So this line is 1 over 2. Should I use, let me use a more thin paper for this. So this is R in. Let's draw it. Okay, at the bottom, R in like this. Then R out. So can you see that at this line here, this line is y equals to half. Okay. This is this half here. R out is different. Okay. So you can see that R out split into two parts. Okay, depend on y. So R out it will be equals to 4. 4, sorry, this is 4 if y is in between 0 and half. But if y is in between half and 1, what happens? Okay. So this line here is this R out here is y equals to 1 plus square root x. Okay, 1 over square root x. So what's the R out from y equals to half to 1? What do you think? What's the R out? Okay, let me ask you a question first. R out radius is in the x direction or in the y direction? Radius is in x direction or y direction? X direction, right? So meaning you need to get a formula say that x equal to something first. Okay, so from this graph, right, you actually can say that x is actually equals to 1 over y squared. Okay, 1 over y squared. Okay, so this means that the axis here, depending on the height. Okay, and then the dependent here is here. Okay, the y we can try at 1 over 2 to 1. Okay, so the r out here is actually 1 over y squared. Okay, so this is like a piecewise function. Okay, so meaning what? To compute the volume, we were gonna split into two parts. Okay, by washer method. Okay, the volume we're gonna split into 0 to half, and then half to 1. Okay, by using a different r out. So from 0 to half, we will just get 4 square minus 1 square here, plus from half to 1, we have pi of 1 over y square minus 1 square. Okay, the 1. Okay, so for washer, we integrate along y direction. Okay, because we are taking the, let me write here, uh, difference of area of a larger circle or larger disk minus and a smaller disk. Okay, does it make sense? Okay, so you compute the larger disk first. Okay, what is the larger disk? You compute the larger disk first, and then you take away the smaller disk. Very hard to see, huh? Let me see how do I show you. So maybe I should bring this blue thing up. Okay, so maybe let me draw here. So the blue circle is like this. So you have a R out, okay, and then a R in. This, so R in is here, and then R out on the other side. Okay, and then you take the larger circle by use okay, you take the larger circle, take away the smaller circle. The area of the larger this minus the smaller this, then you get something else. Okay. So what you integrate over is like somewhere around. At every level you integrate. Any questions so far? Or maybe you want to try this first. You want to try integrate this? Try integrate this. You integrate. I give you 1 minute. Try integrate this. See if you get the same answer or not. Yeah, try and integrate this. Try and integrate. Convinced that you really get the same answer. Yeah. You convince first and then I'll tell you the number. By the way, do you know you can get a free Gemini 3 Pro student? Yeah, please go and register because the offer will end December 6th. So in next week it's gonna end. Yeah. It's not for you to copy solution, but uh you should use it to learn. Yeah, because like my brother is quite experienced. So he teach Gemini Pro how to do the easy question. Then the Gemini Pro will help him to solve the harder question. So you can actually feed the books to Gemini Pro and then talk with him. You can ask him. You can discuss with him. You can feed him a video. You can feed him a book, like our calculus textbook. Then Gemini Pro will speak. You can discuss a question with Gemini Pro. Okay, free student planner. It's not for you to copy your assignment solution, but help you to figure out how you do your assignment. Okay, yeah, it's a very powerful tool. This one, you can try and use it. Okay, use in a good way. Don't copy. Don't say this lecturer asked me to copy here. Later I'll get famous. Okay, yeah. So everyone got this answer already, or maybe you can fit into Gemini 3 Pro to check your solution. Yeah. The other course that I was teaching was quite advanced. I asked him about those advanced knowledge, abstract knowledge. Gemini 3 Pro also can handle. So I think it's a very good model. Okay, everyone got 28 over 3 here. Same. Okay, you can see that there's an over 3 contribution from here because this is 1 over 4 square, right? So if you integrate, it will become 1 over y cube. So there's a 3 cube contribution here. Because when you integrate, the power 3 will get divided down. And then there's a 1 here, so you get over 3 contribution coming. Otherwise, you cannot get this over 3 contribution. Okay, so far, any question or not? Any question about this two-way of slicing our space here? Okay, so you can see that in washer method, right? In this case, it is in the y direction. But for cylinder, it's in the x direction. Obviously, if I turn the revolving axis differently, then this x and y direction would change, right? Can you imagine? Can you imagine what I say? So let's say if I ask this question a little bit different, maybe I ask it to revolve in another direction and resize it. Yeah. Okay. So let's say if I ask in a different direction, so revolve in the horizontal line like this, then this cylindrical method will become in the y direction already. Okay, it's in the y direction. Okay, does it make sense? Does it make sense? So it is not saying that cylindrical shell must be in the x direction. It could change. Depend on how you place your cylinder. Okay, your cylinder may be placed in a horizontal way, or your cylinder may be placed in a vertical way. Okay, depends on how you place your cylinder. Okay, so this dx dy is not following the cylinder or washer method. It's the dx dy is depending on how you place your cylinder and the circle. Okay, makes sense. Okay, please don't remember wrong. The most important thing is how you slice out your space first, and then you think of integration. Okay. Okay, in that case, shall we go to the next question? Okay, how about I let you try this? Give you 2 minutes. Set out the integral is enough. Okay, no need to compute the integral. See if you want to use a washer or cylindrical. Okay, try and set up the integral, and then we can discuss. No need to compute yet. Or you can fit into Gemini 3 Pro to help you to understand. Yeah, try and draw this graph first. Yeah, I give you 2 minutes. Try and set out in the. Please try. In this class, you are free to make mistake. Okay, so please try. Please make as much mistake as you can and then learn from mistake. Because in exam, you are not given chance to make mistake. Your marks will be deducted. And so please make mistake here. Okay, so let's try. Okay, let's try. So before we even know what to method to use first, let's get this shape out first. So the volume of a solid generated by revolving the region in the first quadrant again is above the parabola y equals to x minus 1 square and below the parabola y equals to 1 bar 2x minus x square. About this is okay. So from this wording, right, it kind of suggests that the second parabola should be higher than the first parabola. Okay, because it is above the first parabola and then below the second parabola. Otherwise, if it is the other way around, then this space will be empty, nothing. Okay, so let's try and draw it. Okay, y equals to x minus 1 square is easy, right? Because this is just x equals to y equals to x squared. And then from the first week of material, we know that it is shifted to the right by 1. Okay, this is y equals to uh, x minus 1 squared. How about second one? Again, second one, again, there's more shifting from the x direction and the y direction. But first, you get the basic graph first, minus x squared. Okay, and then similarly, you shift to the right by 1 because x minus 1 squared. But in the y direction, you plus 2. Okay, so meaning you have to shift up by 2. Okay, okay. Yeah. Shift up by 2. Okay, so what's the y-intercept here? So you can actually compute your y-intercept actually is this part. Okay, so y equals to 1. Because if you set x equals 0, you get 2 minus 1, which is 1. And then the other y-intercept is also 1. Okay, so second one is here. So read the question again. We want the volume that generated by the region in the first quadrant. Okay, here is the first quadrant. That's above first parabola and then between the second parabola here. Revolve around the x-axis. Okay, so x-axis is like the y-axis. Okay, any real life example? Any real life example? Maybe like the bun, red bean bun, maybe. Uh, is pinched in the middle. Let me see. Maybe I can introduce one of my home local bakery. Maybe some of you would know. Maybe something like this. Pinch in the middle. Any of the Chinese student would know. This is like from the Hokkien district. Is it? Fuchao food. But pinch in the middle. Okay. Yeah. Slightly the same. Okay, so pinch in the middle part. Yeah. Okay. So anyone try any method? What method did you try? Shell or cylindrical shell or washer? Huh? Any method you try? Okay, first of all, you want to find all the intersection. That one I leave you to do it. So first find all the intersection. Find yourself. But now I want to discuss about the method. Find all intersection point. Okay, so anyone try shell method? Okay, so if you want to try the shell method, you need to draw out your cylinder. So maybe your cylinder will look something like this. Okay, but did you notice that there's some part of the cylinder you don't want? There's some part of the cylinder you don't want. Okay, you don't want the everything below the cylinder, right? So you need to take away some other cylinder, actually. Okay, you need to take away some other cylinder. So you need to take out the smaller cylinder. Um, so maybe for this case, it's something. Yeah. So this is not symmetric, huh? So let me draw it to be symmetric so that we can draw a proper cylinder takeaway. Okay, how about let's draw a cylinder first and then I'll draw the shape. Okay, so maybe you can start with the cylinder, right? But you can notice that there's a bottom part that we don't like. And maybe you need to take away this smaller. Okay, and let's draw the shape again. Okay, so you can think of it as a big cylinder, take away a smaller cylinder. Okay, and then you do it for all the cylinder. Okay. So then what you do here is the shell method we're gonna use here is v from 0 to 2. So 0 is here, 2 is here if you can find the intersection here. So this is 2 pi x of the top, the height of the top cylinder minus the small cylinder or the bottom cylinder. Again, this is the shell method we could use. Okay. Anyone got this? Anyone got this? Okay, so this is like a top cylinder minus the bottom cylinder. Okay, makes sense. Any question? Any question? Any question? No? Okay. So anyone try washer method here? Anyone try the washer method? Or maybe let's copy the shape again. So how about washer method? Instead of cylinder, we will draw a bunch of this. We'll draw a bunch of this here. So for example, this level of this, get something like this. Okay, but we but we don't want to hold this because there's some part that we're gonna throw away. Okay, so here constitute the R in, and then here constitute the R out. Okay, but if you draw another R in R at the bottom, right? Did you see that their radius actually controlled by two different functions here? Yeah, actually they are controlled by two different functions. Because in the first layer, right, you will get something controlled by the y equals to 2 minus x minus 1 squared. But at the bottom layer, you are controlled by another parameter. Okay, so you need to split the R in and R out. Excuse me. Okay. So uh so how do we split this up? So for the washer, right? For washer method, your R in. How about let's draw it? Let's draw it. How many color we have here? So let's use the red one, the black one, and then the green one. I use green here. Let's draw it a more thicker of it, and then purple one, then blue. A blue one, good, not good. About this. Okay, just keep it as a red one. Good. Okay, so R in is actually the black part. Okay, if where's our y? So we need to determine our y. So did we determine that? Okay, we haven't determined that. What's the maximum point here? So the maximum point here is actually 2, if you can find it. And then the intersection point here is 1 and 0. Okay, so we split into basically these two parts. So 1 to 2 and then 0 to 1. So if y is in between 1 to 2, R in is black part. If y is in between 0 to 1, then your R in is the red part. Okay, and your R out. So your R out is green part if y is in between 1 to 2, and your R out is the purple part if y is in between 0 to 1. Okay. So do you know how to describe the black, green, red, and purple? Do you know how to describe them? Maybe start with let's start with the red and the purple first. Let's start with the red and the purple first. This one is easier. Okay. we know that the red and the purple will satisfy y equals to x minus 1 squared. So can you describe these two parts differently? In terms of x, okay? Because we will write x in terms of y. Okay? Because we have to describe in terms of. Okay? So let's write what is x. So from here, y equals to, okay, maybe use. Okay. So y equals to x minus 1 square, right? So we can write that actually square root plus minus square root y equals to x minus 1, and x will be equals to 1 plus minus square root y. Okay, so this part x equals to 1 plus minus square root y is exactly how you split out the two sides of the parabola. Okay, because you can see that this parabola here have a minimum point at 1, right? Okay, so everything beyond 1 is 1 plus something positive. Okay, anything before 1 is you need to take away 1. So 1 minus some positive. And so exactly the purple part is actually 1 plus square root y. So let's use the purple color. And then the green part is, sorry, the red part. The red part is 1 minus. So can you try and figure out what's the green part and the black part? And so you just play around with this. Play around with this. Should I play it for you? Or you can play yourself? I do it. Maybe I can try out. Okay. So how about try the other one? So please believe in yourself. Don't just believe in me. Okay. So if we rearrange this, we get that x minus 1 squared is equals to 2 minus 1. Okay. And then x minus 1 is equals to plus minus square root 2 minus y. And then x will be equals to 1 plus minus square root 2 minus y. Okay, so use a similar argument that we had just now. Because square root is always positive. Okay, so 1 plus the positive number is on the right side. So the green part here should be 1 plus square root 2 minus y. And then the black part should be 1 minus square root 2. Okay, so far, so good. The Washer method now. Okay, on this labeling. Okay, so for example, the Washer method should be integrating from 1 to 2 of pi of square root 2 minus y plus 1 square minus square root 2 minus y plus 1 square dy. And then the second part should be 0.1 of pi of 1 plus square root y square minus 1 minus square root y square. I think for now, you don't know how to do this integration yet. Okay, for now you cannot do this yet. Later we will do it using other techniques. Because this is not circle as well. It's not like 2 minus y square. You can use the area of circle to find it. But we will do it later. Okay, we will have technique later. So later on, introduce new technique to deal with this kind of integral. Introduce new technique later for this kind of integral. Okay. But if you feed it to a computer, it should compute you the same number as what we had just now. Okay. This one is easier to compute because this is just polynomial. Okay. But downstairs here got some square root thing. So it's harder. And we haven't learned the technique yet. If inside here is a circle equation, that's fine. Okay, because you can use the area of the circle to find. But this is not a circle because it's not y squared. Okay, any questions so far? So far, any question? Any question so far? Question? Feel free to ask. As the material get harder, you should ask more. Yeah. So for example, if you fit into Gemini 3 Pro, right, the two methods should give you the same answer. If there's not the same answer, something must be wrong. Okay, you need to check again. Either your method wrong, either your calculation wrong. Okay, so you need to check. Either your substitution wrong. Okay, so far, so good. Okay, seems like people are still struggling. So maybe after the break, we will discuss few more questions again on how to slice out our spaces. Not computing integral, because computing integral is what we did last time. You can compute yourself, but the way to slice this object out is very interesting. Okay, so we need to try. You can try any method. Okay, every method literally. Okay, to slice them. All right, let's break until 11:05.为什么是 Y？不是我有个意思，就是说，对，比如说这个方法一会儿就是为什么全国是为什么有个意思？我什么时候用 X，什么时候用 Y？OK，要看你怎么去切那个用什么东西去切你的那个立体。所以现在要问 Y 的情况，所以 Y 的情况我们是用那个 circle 去切它。你的 circle 是一层一层的嘛，对不对？但是它的一层一层是在 Y 的方向，所以我们就 integrate over Y。它在 Y 的方向，对，它在 Y 的方向。好像对对对对对对对。对对对，因为你可以注意到是这个蛇壳是跟着高度的变化，所以你就把所有的变化，所有高度的变化摆下来。哦，没看到啊。cylinder 的话，它在这个情况呢，这个 cylinder 的话，它是x 的变化，它的高度，所以你把不同的高度加来，所以它在 x 的变化。这个方法它是从 x 的方向来切割。呃，OK，什么叫做在 X 方向切割呢？因为它的 cylinder 的高度是跟 X 的变。画出来，就是你画那个 cylinder 的时候，我有画的，就是你看这个 cylinder，它的高度是你在 X 变化的时候，它会高低不同嘛，对不对？所以你要把这些全部高低不同的东西加在一起。就是它这样子，它的身高是跟随着 x。对对对。那为什么就不是也行这样？什么？就是另外一种方法，为什么它就不是这样？另外一种方法的切割方式不同啊，因为我是这样去切啊，我是横着 horizontal slice。cylinder 是就是 OK，很奇怪一个 horizontal slice，但是你是 integrate over y 的。对，不是因为你是一层一层这样切嘛，但是你一层一层切的时候，其实你要把每一层加起来也是它加起来的方向跟你切的方向是相反的，合理吗？你觉得？不合理没？你觉得不合理啊？因为你想想看，我想想看，我怎么解释这个东西？你觉得不合理啊？比如说你有一个抽屉嘛，你的书是怎么放的？或者这个抽屉嘛，你的书是怎么放的？这样子放上去嘛？ 但是你算基本的时候，你会这样算，你应该是从低算到上面。
对。
但是你的书是平着放啊。
哦，就是它的 horizontal 之类的球就是要。
对呀、对呀、对呀、对呀、对呀、对呀、对吧？对呀、对呀、对呀、合理了，合理了。
就可能竖着切嘛。
呀，
竖着切。
竖着切是什么意思？然后这样切，
你不是说一个
森林的 shell 是这个。
这个就是外面的半径等于里面的半径。这是一种方法，还有一种方法是什么？
还有一种方法是用circle，对，或者叫我是
这两个不是一样的。
这个没有高度，这个只是一圈嘛。
对，就是每一个平面嘛，就是一个大于还是一个小于。
对，没有错。
然后再乘以它的每个高，就是
然后每个高
分段去乘每个高。
没有错。
这个是这个方法。
这个是这个方法。
那这个呢？
这个是那一个圈，你可以想象刚才那一个圈，但是它把它以下的高度
先把所有的算了，再减去中间那个数嘛。这是对，这个是
我想一下。
大的减小，然后这个是乘。
哦，
就这个是吗？
等一下，因为我想一下，你想说。
那我的意思就是，先把这个每一就是实际上也是相当于跟这个有点像。这个先把整个这样子转出来，然后再减去中间的这个圆柱。
是，所以意思说，你看这一个是，哦，我应该讲错了，这不应该是 volume of 我的这个只是 surface area 吧？这是 surface area。因为像你讲的嘛，如果是 volume 的话，我应该要拿这个外面的 volume 减掉那个里面的 volume。所以，但是外面 volume 减掉里面的 volume，其实就剩下它外面那一片。
啊，对啊。
所以其实是 surface area，这个应该不是 volume，这应该是 surface area。因为这个其实是这个其实是这个2 pi x 是这个长度，and then 这个是高度，所以这个只是 surface area。我讲错了，应该这个不是 volume。volume 的话要像你讲啊，我算了这个 volume 之后减掉那个小 volume 里面那个 volume，但是如果外面那个 volume 减掉里面 volume，应该就剩下那个，
就实际上跟这个有点像。
对，其实都是
这个就是实际上就是外面的涡轮。
啊，对，这个情况我们只会叫 area，因为它只是二维嘛。但是这个有高度，所以我们会对，概念是一样的。
这个是有点没理解。
嗯，
就是它这个是上面的，这个是这个长嘛？
对，有说
那还有
这个是什么啊？
对，
这个就是跟刚才一样，就是你的这个 shell 的 radius，这个 shell 的 cylinder
转出来不是一个圆柱吗？
圆柱啊，对，圆柱啊，圆柱，什么问题？cylinder 嘛，对，圆柱啊，跟这个情况一样。这个这个跟这个情况很像。但是只是说，因为你如果注意看的话，这个是它下面这一 part 不要嘛，下面这一块不要，所以我们就要拿掉下面那个。
这个我
这里 OK，那就是这个是一样的，也是一样。
所以这个的第一个方法和这个是一样的。
对，
都叫 area，
都是
surface area。
对 surface。
然后还有一个 volume 的方法是大的减小。
对，那个也是 area，对，因为你没有高度。那
这个呢？这个也，
这个是 area，
这个就是
这个
是 area，
这个是 area，这个我讲错，这个不应该 volume。如果 volume 的话，是应该要减掉中间这个 volume。
其实 volume 跟这个
因为对它的概念是一样的，就是大减小。
只不过是层层叠加。
因为你如果不要减的话，其实比如说我有一个情况是把这里填掉，填掉就不用减了，就每一个 circle 每一个 cylinder 你
都是完整的。
好，你就不用减了。你就 integrate 从零开始了。
你连那种所有的 region 都算进去了。Okay, let's take attendance. Is Yating here or not? Oh, Yating. Tấn Phán here, I think. Yep. Quỷ Ye not here. Quỷ Ye. Hồng Liang. Yeah. Xí He got Lơ Thiên. Is Lơ Thiên here? Okay. Rui Yang. Yep. 若石. Chen Ruo Shi. Oh, yeah. Shi Man. Okay. Yi Nan. Okay. Yu Tao. Yu Tao, thank you. Yi Zhe. Yep. Li Wen got. Rui Yan, I think got. Jia Lai. Uh, Zhe Han. Ne? Fan Zhe Han. Fan Zhe Han. Zhe Han, Fan Zhe Han. Not here. Jia Chen got right. I saw it. Jia Yi. Yep. Qi Jun. Yep. Yi Qing. Yes. Jun Yi. Jun Yi. Ji Jun Yi. Okay, got. Xiang Si got. Yi Ling. I think I saw you. Bing Zhen. Okay. Jia Tan. Okay, got. Hao Yun, I think got. Wen Qi got. Han Xiang. Yep. Jun Jie. Yeah, okay. Xing Yang. Yeah. Wanda got. Xing Yue. Yep. Yu Hen. I think I saw Yu Hen. Yi Tian got. Bing Chen. Miao Bing Chen. Okay. Hao Ran got. Desmond. Desmond not here, huh? Didn't see Desmond. Okay. Tommy got. Chong Yi. Chong Yi. Chong Yi, where are you last week? What happened? Just absent. Okay. Are you okay or not? You okay? Can keep up? Yeah, please ask if you got any question. Just feel free to email. Injie. Okay. Gopani. Yep. Actor, I think I saw actor. Jose got. Hisham. Hisham got. Daniel. Daniel here or not? Daniel. Okay. Hashim. Is Hashim here? Bin Yusuf Hashim. Not here. Not here. Hashim. Madia. Did I saw Madia? I didn't saw Madia. Madia here. Got it. Okay. Aaron, I think I saw. Brandon got. Felicia got. Gunakanti got. Yep. Margaret got. Khalid. Oh, Hassan Khalid already. Shift, right? Javed got. Yep. Gabriel. Gabriel got. Jeffrey. Jeffrey here, no? Okay, good. Purity. Good. Okay. So I have an announcement. So tonight, I have office hour 8 to 10. You can come to the classroom. Where's the classroom? I put on the Moodle. Is A4105. So if you have something to ask for the midterm stuff, midterm exam stuff, up to derivative, so you can come A4105 tonight. In particular, few of you might be coming. So if you have last minute question, you can come. Another thing is this Friday got revision class, right? So please bring question. Try question as much as you can, and then bring question. We can discuss, or maybe I can give some summary. So it's just 1 hour this Friday. This Friday is just 10 to 11. Okay, so please don't come at 9. Not there. Okay, 10 to 11, and then at night another 2 hours is exam. So where's the exam venue? A4, 11, 11. Okay, 111. Okay. So please come earlier. Otherwise we'll have messy stuff. And how many of you fill up the evaluation? Can I see? How many of you? Evaluation? I think half of you, okay? So you guys are quite kind, very kind to me. So thank you very much. So you guys say that this is a relaxing atmosphere. So we hope to keep this relaxing atmosphere until the end of this semester. Maybe one thing need to be improved is my handwriting.
or my drawing. Okay, so if you have any problem with my handwriting, right, on the spot, you should ask me. I can change it. Sometimes it's the app's problem because my apps can auto change my handwriting. Yeah, what's wrong with you? Can we solve it later? Because I'm gonna start class now. Or you can message or email me also can.
There is a few, I think some answer is not similar to you.
Yes. You can send me.
There's
Yeah.
3 or 4 questions.
Sure, you can just send all of them. Okay, so we're gonna start class now. Okay, so there's some mistake here. We don't see this as the volume of cylinder, right? 2 pi x times h. This is the surface area. Okay, because if it is the volume, there's nothing inside this cylinder in the middle here. So we need to take away that volume actually. Okay, actually, after taking away the volume, actually you left with the surface area only. Okay, actually this part, the cylindrical method is a surface area. Okay, we just add a bunch of surface area together. Does it make sense? Okay, if it is a volume, then you need to take away the middle part. But then that's the same as what we have. Okay, so it's not a volume. Anything I want to update? Okay, so maybe there's some counter-intuitive thing that happenings here is why, for example, in this washer method, right? I slice the space in the x direction, but somehow I integrate in the y direction. You might think that this is counterintuitive, but look at your drawer. How do you put your books in? In the x direction, right? But how do you count your books? 1, 2, 3, 4, 5, 6, 7, 8 in the y direction. Okay, so this is what you do every day actually. Okay, it's not something weird happening. Okay, although you put your book in the x direction, but you count your book in the y direction. Okay, if you put your book in the y direction, you will count your book in the x direction. Okay, no? Go to a library, go to the book rack. How do you count? How they place the book? How do you count the book? Okay, make sense, huh? Okay. So I think these are the things I have to say. Okay. In that case, how about shall we skip this? Do you want to discuss this or can we skip this or want to discuss this quickly or quickly? Okay, sure. Okay, let's discuss this quickly. So I think to do this quickly, we need to get the shape out first. So let's get the shape. So set up integral of the volume of solid that result when the region bounded by the curve 3 plus 2x minus x squared and the two coordinate axes in the first quadrant. So the two coordinate axes here will be the y-axis and x-axis. And revolving at different line. Okay, so this is a very important part here. The same region, but revolving in different line. Well, this is a quadratic. So see if you can make it into a basic shape first. So this is a very important technique you're gonna learn, especially important for your midterm. Okay, how to see it in the basic shape. So something to note on quadratic is it will have two roots. So can you find the two roots or not? Okay, so if you write it in x squared minus 2x minus 3 here, actually you can guess the two root is plus 1 as x minus 3. Okay. You can use your sum of root method, product of root method, or you just guess. Okay, you should guess what the two number could pop up. Meaning you need to think about what are the two number that multiply to the constant in particular. Okay, so to get minus 3, right, there's only one way, I think, two way. One way is minus 1 times 3, the other way is minus 3 times 1. Yeah, but how do you sum up to negative 2? There's only one way. Okay. Well, so what this shape looks like? So this quadratic have a root at -1 and 3, but this quadratic is going downward like that. Okay, and this region is bounded by this graph and x-axis and y-axis in the first quadrant. So this is it. Okay. So the first question is easier because your region is like stick to x-axis and then you just rotate right x-axis. So this is like just a bunch of circle in the x direction. Okay, a bunch of circle happening here. Okay, so maybe I can draw a bit like this. Okay, so the circle is like this. Okay, so this one is obvious, kind of obvious. So this volume is just integrating, let's say from 0 to 3 of pi of, what's your radius here? So who control your radius here? Actually is the height of your graph. Okay, this height of your graph will control your radius. Pi equal to 3 plus 2x minus x squared. So your radius is this way. Or your radius is here. Okay, so it's just 3 plus 2x minus x square dx. So this one, okay? Did you learn this in your high school? Okay, I'm not asking China student, but the rest. Did you learn this in your pre-university, A-level or something like that? Did you learn this? No, man? My pre-U got learn this. So revolving around x-axis or y-axis, this single case. I don't know the new syllabus, but previously you got Madhya got? Okay, Madhya got. Okay, so this is the simplest case. Okay, where you get this, because you get a round circle revolving. Okay, from this region. Then you add up all the circle, IR squared. Okay, and then this radius here will change based on your x. For x equal to 0, x equal to 3. X equal to 3 is a point, right? So if you put 3 inside here, this is 0, nothing. Okay, it's a point. When x equal to 0. Okay, the circle slowly diminish to a point. Okay. And then at x equals 0, what's this radius here? Can you compute x equals 0? What's the radius? It's actually 3. 3, right? Yeah, so it's 3. Okay, so at the first slice, x equals 0, it is pi 3 squared. Yeah. Okay, and then you add up all the circles together. All this actually, because it's a filled circle. Okay, next one. I think next one is kind of interesting. So how about next one? Y-axis. You want to evolve around y-axis. Oh. If you evolve around y-axis, what's the shape you're gonna get? Around y-axis, something like that. Maybe let's remove this side here because it's irrelevant for now. Side. Okay, so you will get your solid revolving this way. Okay. Yeah. Okay, so what's the method we can use here? Okay, so one method we could use here is the shell method. Okay, so the shell method maybe it looks like this. Okay, the shell method. Okay, you use the increasing cylindrical shell here. Okay, so the shell, so let me write down what's the radius of this shell. Okay, so you can write what's the radius of this shell. Okay, your radius is going from 0 to 3. Okay. So the shell has radius x, where your x is going from 1 to 3. And then the circumference will be 2 pi x immediately because 2 pi r. And what's the height? Okay, so can you see that if I change the radius, okay, my height would change. Okay, but my height will change based on my function y. 3 plus x minus 2x minus square. But this height here will also depend on my x. So if you go further, you will go up, the cylinder will go up, and then the cylinder will go down. It go up and then go down. Although the radius get really wide, but the height decrease. Correct. So if I draw a wider cylinder, the radius decrease, the height decrease. Okay, so you add all this cylinder together. Okay, so maybe I draw here. So you kind of like go up, go all the way to the top, and then you come down again. Okay, makes sense. So there's a shape. So there's the height of your y. Okay, good. Question. Okay, maybe you can try and use your method, washer method, to compute it. C. How about C? Let's see. Y equals to -1. So where is y equals to -1? Copy, paste. Okay, so let's see where is y equals to -1. Okay, y equals to -1 is a horizontal line, or maybe around here. Okay, y equals to -1. But let's get rid of the redundant part. Oh, yes, redundant. It's redundant. Okay. Right. So we want to evolve this solid around here. So something like this. And then you revolve. Okay. Can you imagine what is this? It's just some block and then you revolve it around it. Maybe you can put a pencil inside, if you like. Okay, so how do you compute this? Huh? Can you think of it as a large circle minus a smaller circle? Large this minus a smaller this. Okay. So maybe you can think of a large this here minus a smaller this. Okay, R in, R out. Okay, so there's a R out here. And there's a R in inside. Okay. Because this is nice, because R out is following some function here. So this is a nicer way to do it. So we can think of this as a washer. Okay, so what's the R out? Is it just 3 plus 2x minus x squared? 3 plus 2x minus x squared is just this part. But your radius comes from this line. This line is y equals to -1. Okay, so you need to add this part in. This part need to add in because you are counting all the way from y equals to -1. Okay, so you need to have there's a distance 1 here. So you need to +1. Okay, so the radius here, y by +1. So there's a radius 1 here. So here is -1. Okay, maybe I use different color. So this gap here is a distance 1 gap. Okay, so plus this 1 gap, you still have a radius on the first quadrant. So your radius change based on this graph. Okay, your R out. And then R in doesn't change. Okay, R in is just what? Okay. You might think that the difference of the radius is still the function y, but in this calculation, you need to be careful. Because in the calculation of this washer method, right, you are taking pi r out square only, then you take away r in square. Okay, So it's not linear. Okay, it's not linear. So you cannot just straight away take the difference and then square it. It's different. Okay, does it make sense? Does it make sense what I say? Maybe I should write you a equation here. So what I want to warn you is warning. A square minus b square is not equal to a minus b square. Okay, so please don't take the difference first and then square this difference. Difference, right? There's an extra term here. Not just extra term, I think it's different. Because it's a squared minus 2ab plus b squared. Yes, it's different. Right? Maybe people try to be lazy. They just take the difference. Oh, difference very fast, man. They just 3 plus 2x minus x squared and x squared. But this is not true. It's not linear. Not linear. Square is not linear. Use your linear algebra language again. Squaring is not linear. Okay, because if it is linear, then you can bring into your number and then take away the scalar. But it's not linear. Seems like every week I need to remind you about linear algebra. How's your linear algebra result? Don't know yet? Huh? Not yet. I thought you guys have the exam.
Yeah.
Oh, only discuss. Okay. Hopefully we can finish marking early also. It's a big group. Okay. Yeah, so this is the for C. How about for D? Okay, for D, maybe I'm lazy to draw. I can show you what I have done. For D, the question is at x equals to 4, which is a vertical line. So it is something here. Okay. So you rotate in x equals to 4. Okay. So it depends on whether you want to use a cylindrical method or the washer method that we discussed just now. But in this case here, I use the shear method. Okay. So the radius here is slightly different. Huh? The radius here is 4 minus x. Slightly different. Okay, why is it 4 minus x? Because you count your radius from 4. Okay, but the real radius happened at this part here. Okay, so let me draw. So here is the radius. Okay, so for example, this part was the radius. You need to take 4 minus 0. For example, this part was the radius. You need to take 4 minus 3 to get the radius. So it's 4 minus x. Okay, and then the 5 is just following your function. So this is the tricky part here for this question. I challenge you to use washer method. Okay, if you found that, okay, so this is the general rules. If you found another method that I didn't show in lecture, you can try it yourself. If you get the same answer or you don't get the same answer, you can send it to me. Okay, if I think that this is good, I will just share it in my lecture note also, and then I will acknowledge you. Okay, just send me. Okay. Any other question for this? Okay, you really have to try it out because you cannot just simply set your radius, set your shear or set your washer without knowing what you are doing. So you really need to try it out yourself. Okay, and then I accidentally do wrong question. I also add an extra question for this question because initially I thought the y equals to minus x is x equal to minus 1, so I computed this instead. So this is an extra bonus question for you if you like. Okay, I put out the solution as well. Yeah. So how to define whether you know a subject or not is if you can come out with a new question, then you are good already. So if you can come out a new question, then you understand the subject well. All right, so let's go to the next part. Okay, before that, any question about slicing the spaces? I think this part is the hardest for now. Yeah. Any question about slicing the spaces? Any question? I think one important thing you want to keep in mind is in what direction you are integrating. Okay, in what direction? Or to understand what is direction you are integrating, you should ask yourself in what direction these shapes are changing. Okay? In what direction the height is changing, or in what direction the thickness is changing. Okay? These things. Then you will have a better idea. I want to integrate along which direction. This will come naturally if you know what direction something, the height or the thickness is changing. Don't try to memorize them. Try to see what is going on, and then the integration will come naturally. Does it make sense? Yeah. Think about how I add things, then you will know, oh, in this direction I don't have. Okay. Right. Let's go to the next part. Go to the next part. Right. So next part is about the average value of a function. So this should remind you about the mean value theorem. Okay, this should remind you about mean value theorem, where we find a mean value of f, but here we call it an average value here. So what's the average value here? If f is integrable, then the average value of f is just integrate f from a to b and then divide by b minus a. Okay, is this an average? Is this the average that you know? What's the average that you know? What's the average of the quiz of this class? What do? You add out the marks of all the students and then you divide by the number of the students. Same. You add up all the marks, fx, and then you divide by how many, what's the interval? Okay, every point. What point? One point get how many? Yeah, average. Yeah. Okay, just that. Just that what we do for your quiz is discrete. So it's number plus number plus number. But here is taking some limit. So this is continuous. Okay. So this is like a, let me write here, continuous average as a limit of some discrete, uh, some discrete data. Okay, so this average is a continuous average. So maybe put like this. Okay, the average that we did for your quiz, for example, is discrete because it's 1 plus 2 plus 3 plus 4. But here is limit. So here is the limit. And you need to take limit. Does it make sense? Okay, limit of some discrete thing. Do you still remember the Riemann rectangle? Riemann rectangle is discrete, but you need to take a lot of Riemann's rectangle. Okay, so it become a limit. So it become continuous. Okay, so actually it's something like this, right? Discrete. But if you take limit, it becomes something continuous. Okay, so this is a continuous case of average. Can we skip this? It's just applying this formula here. So to find the average of this function on this interval, what do? We sum all the value from 0 to square root pi of this function, and then we divide it by the width of this interval. That's it. Okay. Yeah. Let's skip this. Can you recognize that what technique you need to use to integrate this before we skip? Can you recognize to integrate this what technique we could use? And quickly see there's an x square, there's an x. So what should we use? And this x squared appear inside sine. There's a composite happening here. So what technique you should use? Chain rule, right? So it's like a different integration version of chain rule, right? What do we call that? Integration by substitution. Okay, we should use substitution. Okay, so substitution could be y equals to x squared, and then dy equals to 2x dx. Dx. Against 2x dx. Okay? Make sense? Okay. Yep. All right. So let's skip this calculation here. Let's skip this calculation. And then the next part is about application. So when can we use this average value here? So for example, in this question, there is a temperature, okay, of a metal bar, temperature of a metal bar of length 2m. That so this metal bar maybe looks like this, right? Okay, and the length is 2m. Depending on what position you are at, there is a temperature correspond to it. Does it make sense? This temperature could change along the position of x metal bar. Does it make sense? Or do you think that, let's say, uh, this phone, right? Is the temperature the same everywhere? Why? Why? Maybe if you put it to the aircon, do you think that one side is cooler than the other side? Because one side is closer to the aircon. So for example, I'm higher in temperature. So when I touch this phone, right? So the bottom part should be heated, okay? Should be get higher temperature than the other part. Okay, so this is the point of this question. Okay, so the question asked find the average temperature in the bar, and then is there a point where the actual temperature equal to the temperature, average temperature? Okay, so what do you do here? Just the average value, 1 over 2, because the width is 2 here, integrating from, let's say, here is 2 to 0 to 2 of your temperature. Okay, this is just polynomial, so very easy to integrate. But you want to find, so the question said, is there a point where the actual temperature equals to this average temperature? What does it mean? Is this temperature here realized by a temperature function? Okay, so what do you do here? So you need to set Tx equals to the average temperature, and then find x. Interesting part happening here. Okay, maybe I tell you the answer. So T average is something around 160 divided by 3. But what's the degree of this? Maybe 53.333, I guess. Okay, so the question is, can you solve 40 plus 20x times 2 minus x equals to 53.33? Okay, can you solve this or not? Okay, so if you know that this is a quadratic, okay, so quadratic function here, if you can solve one root, obviously you have another root, okay, positive and negative. So if you try to solve this, right, you get x equals to 6 plus minus 2 square root 6 over 6. Okay, which is 1 plus minus square root 3 over 3. Okay, can you take two of these number or not? Okay, square root 3 over 3 is what? What is square root 3 over 3? You can press your calculator. What is square root 3 over 3? Huh? What is it? 0.6, 6 something. Enough? No? What do you get? Can give me more decimal place? 0.6 what? 0.5? 5 what? Anyone can press calculator? 57 ah? Okay, 57. Okay, so 1 plus 0.57 is still less than 2. 1 minus 0.57 is 0.43. So these are the 2 points on your metal bar. So it should be fine. 1.57 and then the other is 0.43. Something like that. Okay. So these are the 2 points on your metal bar that can achieve this average. Okay, very straightforward. Huh? Any questions so far? Okay, this is just about finding average value. So next part is how is this average value useful? Okay, it's what we call a mean value theorem for integral. So if f is continuous, then there is a c that realizes this. This is like what the meta bar happening. There is a c that realizes this integration here. So how do you think about this idea here? So this idea here you can see from this picture. Okay, so you start with a continuous function. Okay, you start with a continuous function, and then this definite integral here is what? Area the graph. Okay, so which is the blue part here? The blue part. Okay, but if you move b minus a across FC, it's another area. What's this area here? This is the width time height. Height is FC. So FC is here. This is the height. This is the width. Sorry. So can you see that? Can you see that this is always true? You can always find a C such that FC equals to, so rather than FC equals to this thing, right? Maybe make more sense is the B minus A FC here, the area of this rectangle would be equals to the area under the graph. This one. Can you convince yourself why is this true from this picture? How about think of this y equals to fx like a wave inside the aquarium? Wave. So if I push the wave down, can this part here feeling this part? In the aquarium, aquarium, you know aquarium? Do you, seems like you don't know what I'm talking about. 水族馆啊，知道水族馆吗？ Aquarium. Or the 鱼箱啊 right? 水族馆. You went to aquarium before? Right, you got a fish, right? And then you can create the wave, right? But after the wave, it will stay still. You know? Okay. Can you see? This part here can fill up the bottom part. Does it make sense? Okay, so continuous function, you can think of it like a wave. But if the wave stop static, then it will stay still, become a rectangle. Does it make sense? Okay, can you remember this? So area under the graph is equal to area of some. Okay, to remember this formula here. Okay, so far so good. Okay, good. Can you imagine that? Can you imagine what I say? So this is like wave, and then the water can fill it to the static part. All right. In that case, let's try some example. I think we should finish chapter 6 by today. Next week we'll start with chapter 7. Okay. So find all the value of C that satisfy the mean value theorem for this integral here. Okay, so this is what? Okay, so we want to find. So let's write down what we want to find. Want to find WTF is what to find. Want to find. Okay, want to find OC such that FC equals to 1 over square root 3 minus square root 3, integrating from minus square root 3 to square root 3 of my fx. Okay, or we want to find that c squared such that 1 over 2 times square root 3 from minus square root 3 to square root 3 of x squared dx. Okay, so can we find the mean value first? Can we quickly do this integration? Maybe you can do quicker than me. Okay, so this turns out to be actually 1. Quite compute it. You compute it? Try and compute it. So cube minus x cube 3 cube. And this is 1. 1. Is it 1? Not 1? Because square root 3 can cancel out, right? And where did I make a mistake? Cube being this guy here. Oh yeah. Thank you. Thank you very much. Okay. Yeah, so this is 1. Everyone okay? Good. Okay, so this means that C has to be plus minus 1. Okay, so the question is this C plus minus 1 here inside our region minus square root 3 to square root 3? What is square root 3 again? I think it's 1.5, right? Just now you tell me divide by 3 is 0.57. So this one should be 1.7, is it? 1.7 something, which is equal to negative of 1.7 something else to 1.7. Okay, make sense? So maybe the picture looks like this. So you have a y square, right? And then you're trying to integrate from minus square root 3 to square root 3. So this is your area under the graph. But there is a rectangle that stay at c equal to plus minus 1, right? So maybe somewhere here, minus 1 or 1 here. They should have the same height. Then what's the width? The width is following your width like this. So this is your rectangle. So meaning the extra part here could fill up inside. Make this rectangle. Okay, any question? So far, going a bit faster. Any question? No, straightforward. Okay, so far so good. Just substitution. Then you can do it for the next one. Do it for yourself. Yeah, you can try this similar question. Okay, so there's a homework here. Okay, but this question here, maybe you will get 2 roots. Okay. One of the root you should omit it. One root doesn't work. One root doesn't work, the other root work, because you need to stay inside your interval. Okay, any questions so far? Any question? Okay. Maybe you can take more times to do revision for midterm for this week. Okay, and then after the midterm, you should come back to integration. Okay. Yes. No need, because I will be here. So you just come. Someone email me already, so I will be around. So you just come. Okay, 8 to 10 tonight. I will be around at the classroom. Okay, any other question? Okay, if no question, we'll see you on Friday. 10 to 11 Friday.
Yeah.
这个方法，
对，
那它是不是如果其实对 Y 它也是适用的？